Generator produces electricity by harnessing the piezoelectric properties of biological material. Scientists generate electricity from viruses. Scientists at the Berkeley Lab have fostered an approach to produce power utilizing innocuous infections that convert mechanical energy into power. Their generator is the first of its sort to create power by saddling the piezoelectric properties of a natural material and could prompt gadgets that tackle electrical energy from the vibrations of regular undertakings. Envision charging your telephone as you walk, on account of a paper slide generator implanted in the sole of your shoe. This modern situation is currently somewhat nearer to the real world. Researchers from the U.S. Division of Energy's Lawrence Berkeley National Laboratory, Berkeley Lab, have fostered an approach to produce power utilizing innocuous infections that convert mechanical energy into power. The researchers tried their methodology by making a generator that produces sufficient momentum to work a little fluid precious stone showcase. It works by tapping a finger on a postage stamp-sized terminal covered with uniquely designed infections. The infections convert the power of the tap into an electric charge. The initial segment of the video shows how Berkeley Lab researchers bridled the piezoelectric properties of an infection to change over the power of a finger tap into power. The subsequent part shows the viral electric generators in real life, first by squeezing just one of the generators, then, at that point by squeezing two simultaneously, which delivers more flow. Their generator is quick to create power by outfitting the piezoelectric properties of a natural material. Piezoelectricity is the gathering of a charge in a strong because of mechanical pressure. The achievement could prompt minuscule gadgets that reap electrical energy from the vibrations of regular errands like closing an entryway or climbing steps. It likewise focuses to a more straightforward approach to make microelectronic gadgets. That is on the grounds that the infections orchestrate themselves into a methodical film that empowers the generator to work. Self-gathering is a much sought-after objective in the finicky universe of nanotechnology. The researchers depict their work in a May 13 development online distribution of the diary Nature Nanotechnology. More exploration is required, however our work is a promising initial move toward the advancement of individual force generators, actuators for use in nano-gadgets, and different gadgets dependent on viral hardware, says Sung-Wook Lee, a staff researcher in Berkeley Lab's Physical Biosciences Division and a UC Berkeley partner educator of bioengineering. He directed the exploration with a group that incorporates Ramamurthy Ramesh, a researcher in Berkeley Lab's Materials Sciences Division and a teacher of materials sciences, designing, and physical science at UC Berkeley, and Byung-Young Lee of Berkeley Lab's Physical Biosciences Division. M13 bacteriophage. The M13 bacteriophage has a length of 880 nanometers and a breadth of 6.6 nanometers. It's covered with roughly 2,700 charged proteins that empower researchers to utilize the infection as a piezoelectric nanofiber. The piezoelectric impact was found in 1880 and has since been found in precious stones, ceramics, bone, proteins, and DNA. It's additionally been put to utilize. Electric cigarette lighters and checking test magnifying instruments couldn't work without its anything but a couple of utilizations. In any case, the materials used to make piezoelectric gadgets are harmful and extremely hard to work with, which restricts the far and wide utilization of the innovation. Lee and associates contemplated whether an infection concentrated in labs overall offered a superior way. The M13 bacteriophage just assaults microbes and is kind to individuals. Being an infection, it imitates itself in large numbers in practically no time, so there's consistently a consistent inventory. It's not difficult to hereditarily design. Furthermore, huge quantities of the bar-molded infections normally situate themselves into all-around requested movies, much the way that chopsticks adjust themselves in a case. These are the attributes that researchers search for in a nano building block. However, the Berkeley Lab analysts originally needed to decide whether the M13 infection is piezoelectric. Lee went to Ramesh, a specialist in contemplating the electrical properties of flimsy movies at the nanoscale. They applied an electrical field to a film of M13 infections and watched what happened utilizing a unique magnifying lens. Helical proteins that coat the infections wandered aimlessly accordingly, a definite indication of the piezoelectric impact at work. Infections adjust themselves next to each other in a film. The last 3D nuclear power microscopy picture shows how the infections adjust themselves next to each other in a film. The top picture maps the film's construction subordinate piezoelectric properties, with higher voltages a lighter tone. Then, the researchers expanded the infection's piezoelectric strength. They utilized hereditary designing to add 4 adversely charged amino-corrosive buildups to one finish of the helical proteins that coat the infection. These deposits increment the charge distinction between the protein's positive and adverse closures, which supports the voltage of the infection. The researchers further improved the framework by stacking films made out of single layers of the infection on top of one another. They tracked down that a stack around 20 layers thick showed the most grounded piezoelectric impact. The solitary thing staying to do was a show test, so the researchers created an infection-based piezoelectric energy generator. They made the conditions for hereditarily designed infections to suddenly sort out into a complex film that actions around 1 square centimeter. This film was then sandwiched between 2 gold-plated anodes, which were associated by wires to a fluid precious stone presentation. At the point when pressing factor is applied to the generator, it delivers up to 6 nanoamperes of current and 400 millivolts of potential. That is sufficient current to streak the number 1 on the showcase, and about a quarter the voltage of a AAA battery. We're currently working on approaches to develop this evidence of rule exhibit, says Lee. Since the apparatuses of biotechnology empower huge scope creation of hereditarily changed infections, piezoelectric materials dependent on infections could offer a straightforward course to novel microelectronics later on. Improvement of minuscule gadgets that gather electrical energy from regular assignments.